so then we'll try our own problem.
Is it weird that we pause video?
Yeah,
So does Freddie Lifer just give me the percentage then?
yeah, like the allele frequency.
So that if I have like 500 people and I get it for, like P is like 0.2, then I take 500 times 0.2 to get the dominant?
To get how many they are, and then, yeah.
Yeah,
Well, if you have 500 people and each person is 2 different, you could have dominant, recessive, dominant, recessive, it's.
But we know that 0.2%.
Okay, guy, Tony, what was your
Or actually-
issue with what you saw in the video?
When you take probability and you pull something out and then pull another thing out without replacing it, you have to subtract one from the total.
Right, yeah, he wasn't talking about pulling it out of the population, like subtracting it from the population. He's saying, if I were to take one of them and examine it, because the P is how many dominant alleles are in that population for that trait, Q is how many recessive. So if you were to look at one allele, what are the chances, what are the odds that it's gonna be a recessive, or what are the odds that it's gonna be dominant? And that's where he got the 3 out of 10, 7 out of 10. He wasn't talking about removing it from the population and
But-
taking it away.
But, so if there's 20 alleles, and you take, say, one red, and you look at all the other alleles that can match with it, there are only 19, there are not 20, so it wouldn't be 3 out of 10, it would be 6 out of 19.
Yeah, but you have to look at the odds. What are the odds that that one that you're looking at is a red? And then what are the odds that another one would be a red? You're not
Right.
taking.
You can't
What
match
he's saying, what he's
itself.
saying is like, if you pick out one allele, okay.
You don't have
you
20
only
anymore.
have 9 more to pick.
but you're not like taking it out of the
Not saying you're
population.
taking
So
it
are
out,
you
he's
putting
just
it
saying,
back?
no,
That's
he's
the
just
thing.
saying,
Can't
what are the
match.
odds that the one that you're picking out of that entire
Yeah,
population is
so
gonna
say
be
you
that
have,
allele?
say you
That's
have
what
like,
Not
Clark's
physically
saying, and
taking
exactly
it
right.
out of the population.
yeah.
Yeah, it's
What are
not
the
about
chances that
pulling
it's
one
gonna
out.
match whatever?
It's just, what are the odds that you will choose a red? What are the
Like
odds?
rolling the die, what are the odds that you're gonna get a 3 or something? Like,
Right.
you're not taking it out of the entire population, you're just saying,
Right.
what are the chances that I'm gonna get this specific allele?
Clark has it exactly right. That's why you don't subtract one. It's not about taking one out and now you have 9 left, okay? It's about what are the odds when you pick an allele that it's gonna be a dominant allele? What are the odds when you pick an allele that it's gonna be a dominant allele? So what are the odds that it's gonna be that? The odds are 7 out of 10. It's not about taking one out and not replacing it.
No, the odds will change because it's a 20 people's population. If the population is like bigger, like 10 billion, taking one out won't change it. That's why they have the equation like that. If it's like a 20 population, they should have a new equation instead of the equation on the board.
Right, but understand something, Stephen, even if you had 10 fruit flies, 5 males and 5 females, each with different traits, you can breed them and breed them and breed them, and you can see if the population, if the frequencies are gonna change because out of 100% of those individuals, they all represent either dominant or recessive alleles, okay? So what are the odds? What are the odds that what you choose is going to be homozygous dominant? What are the odds that it's going to be homozygous recessive? So picking one allele and saying, okay, is this going to be a dominant or is this going to be a recessive allele? There's odds there. If you pick one, you don't take it away.
Oh, we're not taking it out?
You don't take it out.
Okay.
It's just what are the odds if you pick an allele? What are the odds it's going to be dominant, or what are the odds it's going to be recessive? So you don't pull it out. Okay? Now, within the population, what are the odds that someone's gonna be homozygous dominant? What are the odds that it's gonna be homozygous recessive? And it really does work out.
But if you have one,
He's never taken that out.
Like
only
if they're
one
breeding
allele,
it, they have to take it out of the population.
technically what you're saying is that you could pick it and then get it
No,
again
I
and say, there's this really
You
little
can't
chance
take
that someone
one
could
person
be
and
like
breed it to
homozygous recessive, but there's only one allele, so that's not possible. You'd have to remove it from the equation for.
If you had all
That's why.
dominant alleles and only
That's why
one recessive allele, period,
Twenty people population.
then there's no chance that you're gonna get a
But you're
homozygous
saying that,
recessive.
so there's 10, and say there's 10 total and one, recessive and 9 dominant. You're saying that there's 1 out of 10 chance of getting the recessive, and then there's 1 out of 10 chance of getting recessive again? But that's not possible. But we didn't remove it from the equation.
Yeah.
What would be the chance that I would get a rental? If I was.
So, yeah, I see what you mean. If there's a 1 in 10 chance of getting a recessive allele, what are the odds of getting 2 recessive alleles? If there's only 1, then that can't work.
Right.
Well, then the chance would be 0,
Yeah,
right?
it would be 0,
Yeah.
yeah.
Okay, so if we look at this equation, or this problem, it'll help us, I guess, explain the Weinberg equation. So you have a sample of population in which you know that the percentage of the homozygous recessive genotype AA is 36%. Using that 36%, calculate the following. So the frequency of the AA genotype. Does anyone know that? It says it right in the problem.
36%.
Yeah. Because, yeah.
If the frequency of AA is 36%,
Mhm.
then is Q the square root of 36?
True.
Or
The
is,
square root of 0.36.
or is the same thing, you know what I'm saying?
Huh?
Okay. So then Q is the square root of that, but the actual frequency.
Wait, the square root?
Well, yeah, because you have Q squared, and if you're saying that the frequency is.
No, because the frequency is just Q.
Maybe we should identify
Well,
which
I
one
thought you
is
said
P
that
and
the
Q
homozygous
Yeah, we-
frequency
Is Q squared.
is Q squared.
Yeah, guys, it's real easy. If you take Q squared and you wanna know what Q is, just take the square root of Q squared.
Right, but
Yeah,
is
Same
the-
thing for P squared.
But is the frequency of an allele Q or Q squared? Like
just
the-
No, the
It's
frequency
just,
of
it's
Q
called
is
just
Q.
So then
Correct.
Q squared would be
Correct.
0.36 squared?
Yes.
Okay.
Oh.
Okay, so,
Yeah. Okay, that'd be less.
do you get it now?
But Steve, you're right, there would have to be another
Wait, can you
equation
watch
for
the
a
video?
very small population. But Hardy Weinberg even states, it only works if it's a large population, not a small one.
That's what I'm saying.
You wanna put it up?
Cause,
You guys
Tony's
wanna watch
right.
the video?
if you have only one
Yeah.
recessive allele in the population, you
Yeah,
have
let's do this
0% chance of getting homozygous recessive.
Alright,
You wanna-
we're just gonna watch him do this one first, so then you guys can do this.
Okay, so here we go. So,
Here we go.
Wait, so where do you want to start it again?
Oh, he said pause the video, then he was gonna show us me.
So you wanna see him do the equation, the problem?
ask you at this point, or are they talking about people? Or-
I think it's fine.